this problem we want to find derivative. So we got f of x is equal to x squared minus 7x plus 2 over the cube root of x. Well, to begin with, we never want radicals. So let's rewrite that into fractional power form, rational exponents. We can rewrite that as x to the 1/3 power. Remember, whatever number's in this little slot right here, that's called your index, goes in your denominator. Whatever power is in here, if there is one, goes up on top, or just 1. Now, we said earlier in the lesson that if you have a single item downstairs, a single number, a single term, a single radical, a single whatever, there's no pluses or minuses between them, then you can break these into separate fractions. And that's what we're going to do here. So put the x squared over x to 1/3 minus 7x over x to the 1/3 plus 2 over x to the 1/3. Now I want to get a common denominator for the exponents. The 2 I can rewrite as 6 over 3, and that's x to the 1/3 minus 7x, this is x to the first power, I can rewrite that as 3 over 3 over x to the 1/3. And this last one's pretty straightforward. There's no x up here, so I can move this x to the 1/3 up on top. And it becomes x to the negative 1/3. Well, if you got x to a power over x to a power, you subtract a smaller exponent from a larger one. So 6/3 minus 1/3 gives us 5/3, and we're going to have x to the 5/3 where our larger exponent was. So we'll have x to the 5/3 right up there over 1 minus x to a power over x to a power. You subtract a smaller exponent from a larger one. 3 over 3 minus 1 over 3 is 2 over 3. So we're going to have x to the 2/3 where our larger exponent was, which was up on top. And 1 down there. Plus 2x to the negative 1/3. Which then gives us x to the 5/3 minus 7x to the 2/3 plus 2x to the negative 1/3. Now we're ready to find our derivative. All of them are x to a power, so I can take your power, put it out in front, so that becomes 5/3 x to the lower your power by 1, so 5/3 minus 1, minus 7 times, take your power, put it out in front, lower it by 1, so that's 2/3 minus 1, plus 2, take your power, put it out in front, lower it by 1, so that's negative 1/3 minus 1. Well, 5/3 minus 1 gives us 2/3. If you're not very good with fractions, just plug these in your calculator. Minus 7 times 2 is 14. I don't really want you to waste a lot of time on the pre-algebra part. I'd rather you be doing the calculus. 2/3 minus 1 gives us negative 1/3. Now that I made that statement, I'll probably screw up on these fractions. 2 times negative 1/3 is negative 2/3. Hubris. Negative 1/3 minus 1 gives us negative 4/3. Now we don't want negative exponents. We want to take those back down to wherever they were. This one here, the x to 2/3, I can just put that up on top, and 3 there, minus 14, and I'll take this x to negative 1/3 downstairs and becomes x to the positive 1/3, minus 2 over 3x, and I'll take that negative 4/3 back down to the bottom, like that. Again, you move anything opposite where it's at in a fraction, the sign of the exponent changes. Well, I'm going to need to get a single fraction here, so I need to get a common denominator. And they all have a 3, so that's pretty obvious that's in there. Here we got x to 1/3, and here we got x to 4/3. You always go with the x to the largest power. Well, that's x to 4/3. So I'm going to put an x to the 4/3 here. And that's our common denominator. and all of these will have an x to the 4/3. Well, this one already had that denominator, so I'll leave it alone. Now the bottom part, or the first fraction, I multiplied the bottom part by x to the 4/3, so I have to multiply the top part by x to the 4/3. So we got 5x to the 2/3 times x to the 4/3. On this one here, the 3's there, x to 1/3. We multiplied the bottom part by x to the 3/3. We have to multiply the top part by x to the 3/3. How did I know it was x to the 3/3? Because x to 1/3 times x to the 3/3 gives you x to the 4/3. Okay, well, if you got x to a power times x to a power, you add the exponents. 2/3 plus 4/3 gives us 6/3. Now I'm going to go ahead and merge these all into a single fraction since they all have the same denominator now. 3 over 3 is 1, so that gives me x to the first, or x, minus 2, all over 3x to the 4/3, which gives me 6 divided by 3 is 2, so that gives me x squared minus 14x minus 2 over 3x to the 4/3. And that's why I'm going to leave my answer. I'm not going to put it back in the radical form. I don't think there's any benefit to that. Now let me write down that answer. I haven't created a key to the homework. I'm creating it as I'm recording these videos. Now just for fun, so I know we're having that, I'm going to work this problem a different way. There we split this into three separate fractions, and then went in that direction. Let's just tackle it straight from the quotient rule, and then compare the two. See if one's easier. I cannot predict when's going to be easier to split it up and when it's not. Sometimes it's very simple when you split it up. Sometimes it's more complex. Okay. Try to. For fun. Okay. And I'm not going to do all of it here. I'm going to say x squared minus 7x plus 2. And we already said that's x to the 1/3. Okay, quotient rule. Got something divided by something else. This will be our p, and this will be our q. Our formula is p prime q minus p q prime over q squared. So for our formula, we need p prime and q prime. So for p prime, the derivative of x squared minus 7x plus 2 is 2x minus 7. For q prime, take your power, put it out in front, lower it by 1. So I got 1/3 minus 1. That gives us 1/3 x to the negative 2/3. And we don't want any negative exponents, so I'll take it back down to the denominator. So that becomes 3x to the 2/3 in the denominator. Again, when you take anything opposite where it's at in a fraction, the sign of the exponent changes. So the negative 2/3, x to negative 2/3 became x to positive 2/3 when you take it down below. Okay, p prime, we said was 2x minus 7, times q, which is x to 1/3, minus p, which is x squared minus 7x plus 2, times q prime, which is 1 over 3x to the 2/3. All over q squared, which would be your x to the 1/3 squared. Let me do a little bit of rewriting. We got x to the 1/3 times 2x minus 7 minus, and then I'll put the x squared minus 7x plus 2 up on top of that fraction, 3x to the 2/3. When you raise one exponent to another exponent, you multiply the exponents, so that becomes x to the 2/3. Okay, now to simplify this, we got a complex fraction. Specifically, it's a complex rational expression, but a complex fraction. We got a fraction inside of a fraction. The easiest way to get rid of a complex fraction is to multiply everything by the LCM of all your inner denominators. Now, when I say inner denominator, we got this fraction right here inside of the other one. So this 3x to the 2/3 would be our inner denominator, and that's what I multiply everything by. everything. Well, what in the world do I mean by that? Well, here's one group, here's one, and here's one. Reason why this is considered one group is everything's multiplication. This times this. This is one fraction, and then this is just x to a power. Okay, so we're going to multiply everything by 3x to the 2/3. So multiply times our first group minus multiply times our fraction radicals are always just always nasty, in case you're wondering. You always hate to see those in a calculus problem. Okay. Now up on top here, and I won't write all the steps out, but you got x to a power times x to a power, you add the exponents. 2/3 plus 1/3 gives us 3/3 or x to the first, or just x. So again, 2/3 plus 1/3 is 3/3, which is 1, so it just gives us x. This 3x to the 2/3 cancels that one. And the negative that's out in front is going to flip the sign of everything there. So that gives me a negative x squared plus 7x minus 2 all over. And again, if you're multiplying x to a power times x to a power, you add the exponents. 2/3 plus 2/3 gives us 4/3. Multiply this through. 3x times 2x is 6x squared. 3x times negative 7 is negative 21x. Minus x squared plus 7x minus 2 all over 3x to the 4/3. Combine together like terms. 6x squared minus x squared is 5x squared. Negative 21x plus 7x gives us negative 14x. The minus 2 carries on. And then 3x to the 4/3. Now I actually skipped 1 or 2 steps in there, so it actually is about the same amount of work. So it didn't save us anything by splitting it up. We didn't have to deal with complex fractions, but this isn't bad to see both ways of working this, because you'll run across these techniques, both techniques, throughout the course.